Welcome everyone to geometry. We want to take a look at circles and spheres today. So we'll start off with some basic definitions, of course, and then develop some ideas such as circumference, area, and the like. All right. So circles are again something that students are super familiar with, right? You've known about circles for a long time, but maybe you haven't thought too much about what a circle is. If you've had other courses with me, such as Calc 2 or college algebra, you might actually have had quite a bit of discussion on what a circle is. But maybe you haven't had those courses with me. Maybe you haven't really thought about what a circle is. So a circle is defined by a point and a number. So if we consider a point in the plane and take a number, then the circle of radius r is, or the circle of radius r centered at P is the collection of points that are all r units away from P that are in the plane. Okay, so it's all the points that are r units away from P. Excellent. Of course, the number r is called the radius of the circle. And if you wanted to, right here, if we take the point P and we simply start collecting things, collecting points that are some fixed distance away, as we collect more and more of them, we suddenly realize, hey, what we have here is a circle, right? So this distance is r. That is the radius of the circle. So it is the collection of points a fixed distance away from a point. So let's take a look at some definitions that give us relationships between a circle and a polygon. So a circumscribing circle is a circle that contains all the vertices of a polygon. And we say that that circle circumscribes the polygon. So if you want to see an example of that, we've got a quick example right here with this hexagon. So here's a hexagon. So this is a regular polygon, six-sided. It's a sixagon, right? We've got a circle that contains all of the vertices of the hexagon. So this would be a circumscribing circle that circumscribes the polygon. Excellent. Excellent. So the center of a circumscribing circle is called the circumcenter. So here, this is the center of the circle. Well, I guess it's really here, right? That's the center of our circle, so that is the circumcenter of the polygon. And we have a little bit of further interesting information, which may not initially sound interesting, but with a little bit of extension, we can find something interesting. So in a regular n-gon, an apothem is a segment from the center of the n-gon, right, from the circumcenter to the midpoint of a side. So here we have A, which is that apothem. Okay, so this line here is the apothem of our diagram, of our hexagon here. So each apothem is perpendicular to its side. So this apothem is perpendicular to this side, and represents the height of the triangle that's formed. Right? So here, the triangle, the apothem gives the height of this triangle. And of course, as I've been saying it very carefully, apothem is pronounced apothem, not right. It's like apathy, apothem, not. Now I can't even think of how to say it otherwise. Apothem. Ah, that's the other one. Apothem. It's apothem, not apothem. Think of saying this with a lisp. Don't say that with a lisp. Say apothem. Okay? Excellent. So a little bit of language there, but then something that I found really interesting is if you're trying to find the circumcenter of a polygon, this sentence here describes how to do that. Each apothem is perpendicular to its side. Okay, so if we find a line that is a perpendicular bisector to each side, so find the perpendicular bisector to each side of a polygon, and the single point where they all intersect would give us the circumcenter of the polygon. Okay, so that tells us how to find the circumcenter by finding perpendicular bisectors. Now, if your perpendicular bisectors don't all meet at one point, then there is no circumscribing circle. So that's kind of interesting. That detail is not something that I think that we're looking at. In fact, I suppose it could show up in the problems, but I didn't look through them. So that will come up a little bit later when we investigate triangles specifically. All right, so let's take things just a little bit further now, a few more definitions. So if S is the length of a side, A is the length of the apothem. I just did it, I said it wrong, apothem. If A is the length of the apothem and P is the perimeter of the polygon, we have the following relationship. So the area and perimeter of a regular n-gon are given by, well, we can actually take a look at this a moment. So the perimeter, right, if S is the length and there of a side, right, if it's a regular polygon, we're looking at a regular n-gon here, regular n-gon. So each side length is the same, and there are n of them, and they're all length S, then of course the perimeter would simply be given by P. P is perimeter is equal to the number of sides times the length of each side. That's easy. Okay, what about the area? That one's a little bit more interesting here. Of course, there's a few different ways that we can do this, but here we have the example of the hexagon. So we take this regular n-gon is what we're interested in. So there are n triangles that will be made. And when we look at this, we have right, these triangles. The height of the triangle is given by A. The base of the given triangle, yes, the base of the given triangle is S. So S times A, but we only want half that, 1/2 S times A, 1/2 base times height. So 1/2 base times height area is equal to 1/2 S times A, but there are n of these triangles, SAN. Now maybe you don't like the way that that is. You can rearrange those letters as needed, but this would be our equation for the area of a regular polygon. So these we want to use. Maybe we knew those already. Of course, those aren't specifically relating to a circle, but what we want to do is we want to use this along with this fact right here, right, this property. Every regular n-gon can be circumscribed. We want to use these two things to help us in this next activity to determine the circumference and the area of a circle, right? The circumference is the perimeter of a circle. What is the length of the perimeter? Excellent. So we'll pause here for now. And what we'll do is we'll get back together here shortly for an explanation on how to approach this activity. So I'll help you guys start it out, and then I'll let you finish that activity up. If you have any questions for that activity, of course, ask when we're in lecture or send me an email. Get in touch with me. Have a wonderful day. I will see you guys again soon.